welcome.
Thanks for having me.
Thanks for being here with us today. Cheers.
Cheers, fella.
Cheers. So, Kraig, you are the chief data scientist for Concirrus.
Correct.
Which is a data-focused InsurTech company doing some interesting stuff in the insurance space. But you're also a very well-rounded data leader. Prior to this, you were in corporate banking. You were a director for Credit Suisse.
Correct.
And you've also got a entrepreneurial side to you as well, being a co-founder of a tech business a while ago, Data Mantis. So, clearly a lot of information, a lot of wealth of knowledge you can impart on us today. So really looking forward to the episode and picking your brains as a data leader. So let's start where we always like to start, at the beginning. And if you'd be so kind to tell us a bit about your journey into becoming a data leader and what inspired you to get into the data field in the first place, that would be awesome.
Oh, thanks, Guy. Thank you for having me. So I guess I started out life as a electronic and computer engineer. That was my first degree. And what really got me into that was at the time we weren't walking around with like supercomputers in our pockets at that time, right? So there wasn't a lot of gadge, right? So if you wanted gadge, you wanted cool stuff, you'd have to make it yourself. And to me, that was all kind of like magic. So that's what engineering for me was like learning magic. So that's what got me into that stuff. But what I sort of realized towards the end of the degree was, I was designing computer chips and doing really cool stuff, but it was all really small and, like big is better. Oh, don't get me started, right? So I wanted to get into how do I build like plants and giant machines and, robots that can take over the world and, that sort of stuff, you know what I mean? So what I decided was I went into control systems engineering. So It kind of took all my knowledge around electronics and all that good stuff and all the stuff that you learn, but it sort of scaled, it was sort of from micro to macro level. And it also, like talking about three-phase power and all that cool. Basically, I'm attracted to danger. So it was all that cool stuff. And so I started working for the largest whiteware manufacturer in Australasia. It was a really amazing job. I had an incredible mentor by the name of Jim Kraig, who made me the engineer I am today. And and basically I did everything from sort of laser welders to, multi-ton presses or 20-ton presses to, conveyors to folders, or you name it, we worked in it. And that was one of the first times where I was sort of exposed to understanding and not being freaked out by complexity. So, I'd turn up for a breakdown or something and it'd be like, you'd open a cabinet and there'd be literally thousands of wires and you're like, I remember my first few days I was thinking, I can't do this, but what I learned was, how to break down a problem and how to see the wood for the trees, so to speak.
Yeah. Very important in data.
Yeah, and that sort of stuff. And so so it was a really amazing experience there. And then I sort of got a bit academically bored, so I did a master's full time while I worked there. So I didn't have much of a life, but it was amazing. And I was strangely, it was a very mathematically focused master's. It was very heavy on maths. But one of the courses I did was, I guess, what we would probably call modelling now. There was a gentleman there, Professor David I. Wilson, changed my life. And it was like, I walked out of there so cocky thinking I could model anything, and he was just what a legend. And that sort of stuck with me for a long, long time.
Nice.
So anyway, that was sort of in the back. So, a few days after I graduated my master's, I was on a plane to England, had enough money for a one-way ticket, and enough money to survive for a month and, back yourself. So, and then, so here I am now. But I basically fell into sort of the oil and gas renewable energy sector. I think I've probably made enough renewable energy machines to have multiple lifetimes of negative carbon footprint, to be honest.
Okay, good work. Well, thank you for that.
Yeah.
On behalf of the rest of the human race.
Yeah. So that's kind of, always a bonus that it's your job, And so I did so I built plants all around the world. I designed Europe's first coal bed methane facility. Revolutionized, to be fair, the landfill gas industry. Some of these sites had to have nuclear grade control systems on them. If they were off for an hour, the fines were bad. If they were off for a day or two, people started going to jail, sort of stuff. So, that was really, really cool. And but I always sort of had this niggling thing in the back of my mind about the modelling and cool stuff. So I started sort of predicting the fuel consumption of engines and things like that. You know, these things were containerized, big V16s, you know, the size of a shipping container. And that was really fun. But I kind of kept thinking back to, you know, when like my induction on when I was an apprentice, when I first got to that whiteware place. And I remember I was with this old sort of grizzled Sparky who was very lazy, and, you know, and he had to take the green guy around, show, you know, and we got called over to this big machine, and, you know, this guy had been, you know, the man on the factory floor, you know, he'd been working this machine, I think, for like 14 years or something. So he knew every noise, wiggle, you know, everything about it. And I'll never forget. And he said to the you know, the most senior electrician, you know, industrial Sparky, he said, "Oh, this conveyor's going to break." And he was like, "You can't call me over here to fix something that's not broken." And he's like, "Yeah, but we're on Smoko, you know, we're on break. Can you fix it now?" And he's like, yeah, whatever. And off we went. Sure enough, about an hour into production, it split. And they lost thousands and thousands and thousands in production. And so, you know, I always thought, well, wait a minute. I learned all this cool stuff from David around modeling. Couldn't I create something that could learn what that guy had learned in a shorter amount of time? And then what sort of really sort of sparked it was I was on a site where I had two identical engines next to each other, which was quite rare because the manufacturer loved to change them all the time. Right. And they were on the same fuel, but the guys there would be like, "Oh, can you restart that one because it likes you better?" And, you know, they'd almost have to do like a rain dance or, you know, and it was one of those things where the tolerances, differences in tolerances of everything added up to a very different personality, even though these things were supposed to be the same. And I thought, okay, so it's not just a problem about being able to predict and, you know, understand stuff, but even when you've all got the same stuff, they're all different. So I thought this is actually a big problem because, you know, certainly in that world, like if a new alternator or something like that, that's at least a 6 to 8 week lead time. And you can't have all these things, all that capital sitting on the shelf, right? So I started a PhD at Imperial College.
Oh, yeah.
In what's called prognostics and diagnostics, which is basically trying to understand the sort of the health of a system and then basically work out when it's going to die. Okay. yeah. So it's kind of like saying, the doctor's saying, "You're not good, you got 3 months to live." Right. You know, or if you don't change what you're doing now, you're going to die in 10 years or something, you know. Right. So it's one of those things. And then, it sort of got away. And so I got to put all that great stuff I'd learned from David into practice, and it sort of ran away with itself, really. And I then started doing what we now call data science in every sort of the food and beverage industries and things like that. So everything from fish farms to the whiskey industry, you know, like trying to stop the angel share and all that sort of fun stuff. And you know, really highly combinatorial problems with these like sort of 80 components or ingredients and things like that, where they're trying to understand, you know, why stuff just randomly comes out rubbish, you know. And that was really, really fascinating. And then from there, I kind of got poached to a tier 1 investment bank, and I ran like I guess you call it like a skunk works, like a top secret team to create tools that could discover rogue trading. So rogue trading is basically what sort of brought down or caused the first financial crisis, where you know, traders are very much like gamblers. You know, they're taking punts on things, but you know, there's so many systems and ways that you could like accidentally go, "Oh, do you know what? Hey, buddy, can you put this on your book for a while because I'm like way over and I'll trade myself out." And so there's all this sort of horse trading going on in the background. And but you know, there was like, I believe there was over 800 systems, right? So it was very easy for people to move things around and for those sorts of situations to happen. So I designed a system there that was completely unsupervised, that was able to basically work out when people were up to no good, and that was brilliant. And then, sort of after a while, I decided to productionize my PhD. So I had a startup for a while, which was going amazingly, swimmingly, really, really proud of it. But then COVID hit, and sort of everything kind of died, which was a real shame. But I wouldn't change that time for anything. It was, you know, going through and, you know, getting funding and all that stuff. That was, you know, an eye opener for me. It was really a really great experience. But then. Imagine. And then from there, I know I'm jumping and skipping a few things, but I'm trying to keep it the correct version.
All good so far.
And so I started, I was a little bit, sort of fell out of love with data science a little bit because I've been working day and night on my business and stuff. So I went back to systems architecture, and I worked for a DevSecOps company. So that's all about, you know, personally identifiable information and making sure that stuff doesn't get to the, you know, the wrong people and things like that. So if you ring a help desk, they can't see your credit card number and all that cool stuff through systems. And then I ended up running their data science team as well, which was really, really fun, and converting them into big data technologies like Spark and all that cool stuff, so which was great, and designing that product. And then from there, I got recommended to the job I'm in now. I used to run something called the Machine Learning Affinity Group at that bank, and the gentleman who ran it, who would only entrust it to me when he handed it over, he's the gentleman that who recommended me for this position. So we used to, I think at the time there was anywhere from 30 to 50,000 people who worked for that bank. So we used to regularly, every sort of week or two, sort of do sort of debunking, or I'd like to do debunking, or sort of put everything in simple terms around how these technologies work. And so it was a really cool opportunity to sort of spread sort of AI and data science and stuff when it was kind of in its much more in its infancy. So that was really cool. And so now I'm in InsurTech. So it's a really, really cool space. We basically, I wouldn't say we create pricing models, but we kind of, they're more like risk or exposure models, where we help insurers understand the amount of money that was going to be claimed from a policy. Okay. And then they can essentially adjust their premiums to make sure that they're not going to be out of pocket,
Okay.
And so it's really interesting. We kind of we build them in sort of two models. We've got they're kind of two models in one. So the frequency part is what I like to call, it's easy to spot an idiot. So we put lots of behavioural stuff in there, in terms of, we all know the friend that we've got that you'd probably never let them drive your car,
They've got many.
Yeah, they're bound to have an accident, but you don't know how bad it's going to be. Yeah. And so the other sort of side of this sort of stuff is the severity model, which is all about, like if it goes wrong, how much it's going to cost you on average, sort of thing. So, which is much sort of more tricky to pick, because like you can imagine, someone's left the handbrake off in their car, it rolls down a hill, misses an old lady, goes past a school, luckily nobody's out, goes down the hill, through an intersection, somehow manages to misses all the cars and then gets a little scrape when it stops. That stuff can play out very differently. So that's one of the things in that world that's really like a cool challenge, is to understand how, is that perfect storm going to happen, or, and sort of try and find that sweet spot.
Cool. Awesome. Thanks, sir. What an interesting background.
Thank you.
Genuinely, I've heard a lot of those, and it's very interesting. And I love what you were saying. There's obviously a lot of parity and parallels between, an engineering and analytical mindset and the world of data. And like you said, I love this point you made about not being overfaced by a problem, because I guess that's the most important thing in anything in engineering or data, really, isn't it? How do you tackle a big, seemingly messy problem? Yep. And really simplify it into an elegant solution. So I love that. So InsurTech then, when you talked about being interested in fueled by danger, I wasn't expecting insurance to be the end point of where we were going to go, but it is where we are. So talk us through your experience. I mean, insurance is an area that seems quite ripe for disruption, and a lot of AI, machine learning, applied to it in recent times to create efficiencies. But I'm interested to understand your background as a broader data leader, having now gone into the insurance space. Where do you feel actuarial data science and the world of more general data science and machine learning, let's say, where do you feel those worlds sort of interact and converge?
To be honest, I find there's like a real parallel from when I was sort of doing electronics, and it was all sort of, embedded systems and stuff, where, if they trusted you to do it and you did it and it didn't bug out, that was good enough. Versus, the big machines where everything's visible, and they need a screen to understand what's going on, and they're asking questions. I kind of feel like machine learning is going through that sort of thing right now, where, before machine learning seemed to be very much a sort of esoteric, very bespoke sort of thing. You create that module or that, that API or whatever, and then it was like, and if you did a bit like mathematics, if you'd done the process really, and you'd follow the pattern, you did everything right, you would, as the data or machine learning engineer or data scientist, you'd trust what you did, and then everybody just by default trusted you, way it goes. Whereas, from the I'm not an actuary, but the the view that I've had on their world is, they've all been about explainability since day one, and they're amazing at it, and the way that they do that. So, machine learning now is, we've got these things like, I don't know if you've come across things like Shapley values and stuff. So we're trying to explain the importance of features, things that are driving models. Whereas in the linear or actuarial world, more generally, that they have weights or coefficients that explain that stuff really easily. And in the real world, there are these sort of complex interactions that happen and things, but it's much easier for our brain to, as a starting point, to think about things individually in terms of how they're contributing, and then work from there. And there's no, people are now like not scared of the technology and things, right? They're like, but why? But why? So now you really have to back it up with what you're doing. So what I love is there seems to be this, it's like the new school is learning from the old school again about, how to do it right. And I love that. And so we've now got this sort of like, this really lovely middle ground where I guess I'd call them like linear-esque models with, these additive things where you can sort of see how much importance each feature would make, but each component is non-linear. So you're still able to capture all sorts of extra interactions and things like that. So it's quite an exciting space, but it's what I've loved is the ability of all the great things that actuaries do and stuff. There's so much insight and it's I don't want to say theory and practice difference because it's probably an unfair, but what I'm saying is like they've had to be public facing the whole time in terms of explaining what they're doing, and I think there's a lot of learning that can be taken from that into machine learning now, where people need transparency, they need to have explainability. And by all accounts, we've got some regulation coming in next year. Which I think is a great idea, just for that, because some of these things decide whether you get a mortgage or or whether you're guilty or you should get a job or all these sorts of things. And so that sort of stuff is really, really important. But I love that in our journey that we've been able to learn so much from the actuarial community. It's been great.
Nice, yeah, that's really interesting. I mean, I guess the term AI is getting wider adoption in the world that we live in now. Then you've got to look at things like ChatGPT that have obviously had mass adoption. The world of machine learning, I guess, is evolving at such a pace now. And you've worked in renewables, you've worked in InsurTech, you've worked in banking. Really keen to understand from your perspective, what other applications of machine learning are you most excited about in the world in general now? It can be outside of InsurTech.
Yeah, I mean, to be honest, I think I'm quite excited about sort of taking a check right now of where we are, because if you look at like Wigner talked about the unreasonable effectiveness of maths, right? You look at things like graphic processing and stuff, right? Those deep neural networks are not really looking at the whole picture at a time, right? They're doing it in segments and things like that, and then somehow the results that they can produce is just so much better than you thought they could, right? And then you look at things like large language models, like, the GPTs of the world and things like that. They're predicting one character at a time, and yet suddenly you can talk to them like they're a teacher, So these to me are what I would call like emergent properties that are coming out of these things. And, people talk about, what is consciousness and all that cool stuff as an emergent thing. I think we're seeing it now in terms of, things being greater than the sum of their parts. Mm-hmm. I think this is, for me, is like as a real turning point in terms of, like, this is amazing stuff. And, you just have to look at like the human eye, for example, that behaves digitally. I mean, I don't know if you've ever looked at a cartwheel and it looks like it's going backwards slowly, or a propeller or a helicopter wheel and it looks like it's going back slowly. That's called time aliasing. That's telling us that the human eye takes regular samples. It's not continuous. It takes regular samples, and if it's not sampling fast enough, stuff starts like going backwards. So wait a minute. So the human eye behaves digitally. So it's not. I'm starting to think, this is not an us and them thing. I think these technologies are a little bit closer to real life than people actually realise, in terms of, a lot of our systems are behaving the same.
Absolutely, yeah. And think about the human brain in terms of the way neurons work, and obviously are firing along a synapse, and it's no different really to, like you say, just one neuron speaking to the next neuron to predict a behaviour. It's no different to one part of ChatGPT picking the next character based on probability and so on.
But also, people seem to think of us as like analog systems, right? Yeah. Where like where there's no click, 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 like a processor or one of those sorts of things where it's all just live, the whole time, analog.
Yeah.
But like I said, with the human eye and there seems to be digital sampling. That's digital signal processing mathematics, right? That's kind of freaky.
Yeah, absolutely.
Yeah. So I think we're going to see a lot more technologies coming out where they're just they're unreasonably good at what they're doing. Do you know what I mean? And that's the whole thing about machine learning, right? These are all tools that hopefully will combine to produce AI at some point, right?
Yeah.
But I think, we should be really amazed with what we've already done. And I think we're sort of evolving quite quickly, and we just need to realize that these things are quite amazing, and the power of these things is definitely emergent. So I think, the next sort of 10 years is going to be quite incredible.
Yeah, I totally agree. I mean, if you look at actually how far we have evolved I know ChatGPT is not the first large language model that's existed, but it obviously is the one that's, I think, achieved most widespread recognition and adoption, and I guess it's because they made it public, right? It's obviously a clever move from that regard. But yeah, if you look at what we've actually achieved in the last sort of few years and scale of how long mankind's been around, it's a blink of an eye, isn't it? And it's very exciting to think, actually, what is that next sort of 10, 20, 30 years look like?
But also, the thing that's most comforting about it is that you still need that human element to train these things, to create the data in the first place for the most 100%. Part, right? And all of that learning has come from human writing. Do you know what I mean?
Absolutely.
So I love the fact that the human's baked into it.
Yeah, absolutely. And it only means anything in relation to how a human uses that information anyway, isn't it? So it all boils back down to that. But no, I think it's a very good point. Okay, cool. Well, let's talk a little bit about you as a data leader then. Obviously, years of experience, and I'm always really interested to sort of pick your brains on how you approach, I guess, this sort of concept of breaking down a large problem. So are there any particular methodologies you would use habitually, irrespective of the situation, the domain, the type of problem that you would use to successfully execute a data science project, let's say?
Yep. So from an engineering perspective, I would say what makes a great engineer is being able to break a problem down into the right number of parts. Too few and each part is overcomplicated, and too many, the system as a whole is too complicated, right? So if you've got that skill set to break a problem down into the right number of parts, you're away laughing. In terms of data science, I think one of the major things that needs to keep happening is sort of, I talked about it before, there's the human in the loop, is having an SME. So, because what's great about that is, just think about things like, feature selection or stuff like that. Having a sort of a ground truth of, or at least of what they think is driving the problem and understanding it, straight away you can either prove or disprove a whole bunch of urban myths or thinking, or where they haven't had the data before. So straight away that's great in terms of confirming what you're doing, but also that old one of about correlation is not causation, right? I can make you a model that models sunspots on the moon to predict the price of fish, right? It's just an exchange rate converter thing. But there's no relationship between them. So that's the thing you have to really watch out for, right? Is that you're actually trying to describe the problem properly. So having an SME in the loop is really, really important. And it can be like really insightful or really obvious, but it gives you a great starting place. And like an example I had, it's quite a simple problem I had, was I got called into a business where they couldn't understand why their production figures were low, when every time they walked past the plant, it was running at basically 100%, right? They couldn't understand what was going on. So I obviously got all the data for it, but then I spoke to the the manager of the floor, and I said, okay, so how is this machine actually run? They're like, oh, well, we have 3 shifts, we have like 5 teams, they rotate. But, this is all really sort of good sort of knowledge about the problem, right? And this was a classic. I just basically went, okay. So I got the HR information about where the shifts were and the teams and blah blah. And I just basically dissected the thing by shift. And sure enough, one shift was way below their production levels than the other. And I was like, oh, that's interesting. And then I just took that shift and I went day, and then I divided by day of the week. And then Monday was terrible, and Sunday was 0. So I was able to go back to the SME and go, I'm guessing you guys don't work on a Sunday. And he's like, oh, yeah, sorry, I forgot to tell you that. So that's good to confirm that. But what it turned out is they were cleaning the machines on a Sunday, and then everyone was coming in at 6 a.m., but they weren't saying anything because it basically meant they could go and sleep in their car, or they could have just talk and drink coffee and muck around till about 10 o'clock, because all the management were coming in on a Monday morning to do their leadership calls. So nobody was walking past the machines.
Right.
So, just by understanding how that system worked in terms of how it was being operated and that SME knowledge meant that, literally within an hour, I'd worked out exactly what was going on, and nobody was telling the management that the calibration of all the machine was being knocked out by the cleaners, and nobody cared because they wanted a big break. So having the SME in the loop is really important.
Yeah, I can imagine.
Yeah.
Okay, cool. What about how teams should be structured within a business for successful data adoption? And I guess I'm talking about things here like, data mesh. It's this kind of newfangled terminology that's come out that I think, is interesting to see how it can be adopted in different ways. But what's your take on that, and how do you feel projects and teams should be structured efficiently within organisations?
I think without sort of stating the obvious, the key thing around data is being able to actually get it to the people, right? So they love to call it democratization of data and things like that, Yeah. But basically, there's been a history of having sort of these centralized teams and these big server farms, and basically they're, like it's a little bit like a jack of all trades. They don't really know the data in detail of any one thing, but they're trying to be all things to all people, and they're also the gatekeepers. And so sort of big data has had this challenge historically where there's just always this one bottleneck. So I really love ideas like data mesh, where you kind of basically, the people who produce the data are responsible for the data, and they also kind of know who should and shouldn't have access to it. So it's kind of having almost like a democracy or like a parliament about how you manage everything. And what I really love about it is this whole, is not being locked into any one vendor, being able to connect to this, connect to that, and it all sort of has this one abstraction layer that looks that all beautifully organized. And the most important thing there is being able to bring your own tool. Like people talk about bring your own device and stuff, but like not everybody is going to be able to know SQL. Some people like Tableau, some people like Power BI, or ClickView or whatever, right? Or they want an Excel plugin. So it's really, that whole democratization thing is really about being able to expose, sort of like things like JDBC connectors and all that good stuff, so that people can use the stuff that they're comfortable with, but it doesn't really matter what they use as long as they can get to the data, Yeah. And so that's one of the things we're building at the moment, is exactly that. So we can literally click in customer data if we want to. We can click in all these different data products we're building for different industries, segments of insurance and stuff, so that... and what it means is if you have these things, what they like to now call data as a product, or a data product, it means, if you take a little bit of this and a little bit of that and a bit of this, suddenly you might have a whole new product. And instead of spending months and months trying to have SLAs agreed of access and pipelines, and it's all self-service. So you go and hit it, you get it, and away you go. So we're really hoping this sort of approach will also have a real benefit on the sort of rapid prototyping and things like that. And also, you can't always be reliant on a data engineering team to export stuff for you, right? For this stuff to be scalable, it has to be self-service. So, we've learned a lot over the last sort of 10, 20 years in terms of big data, right? In terms of what does and doesn't work. And I think this is a really good step towards making things a lot easier.
Fair enough. Can you see any limitations, I guess, of a decentralized data architecture and kind of big concerns, or the good result of implementing
Yeah, absolutely.
data?
So the biggest, as usual, the biggest problem is probably the human element, right? So because each person has to sort of own their own domain, and like the production of the data products is not really a big deal, because chances are they're producing that data product for some kind of internal system or some report or something, but they're sharing it because it might be useful to somebody else. So it's not so much that, but then it's when you've got the sort of the communal administration, making sure that you keep that working and functioning in as sweetly is important, because everybody gets busy and things like that. So, but I think, a job shared is probably much easier than having one team having to be hammered all the time. And so I think once you've got the culture set up right, I think it'll be a winner.
Fair enough. Do you know any examples of kind of big companies that have implemented it and absolutely smashed it so far?
I think it's pretty early days at the minute in terms of, I wouldn't say smashed it, because there's often a lot of sort of technical, stuff under the bonnet that can get in your way, and especially like in larger organizations, there's very strong borders between, they're almost like broken up into smaller businesses, do you know what I mean? And so you sort of run into that initial problem of just getting the data, do you know what I mean? But I think, I do know, I won't quote them now, but there are some really good examples where, they've used data mesh with Kafka, for example, for high-speed messaging, and the beautiful thing about it is, for example, if you don't really need a high-performant thing, you can just store something in S3. If you really need, real-time access, you can put a really clever database behind it. But to the user, the queries, nothing changes. And for me, that's the one thing I want, is I don't want all my pipelines, I don't want all my scripts to suddenly have hard-coded passwords, heaven forbid, and things like that. But what I really don't want to have is to be changing the way that I write that SQL or those requests to that system. So I need like a foundation that doesn't change, and then everything behind it can change. And that's the bit that I really love about it, is you can swap out technologies under the bonnet, but at least you can keep that organization layer at the top so that everybody knows, and it's searchable, and it's got audit trails and role-based access or security groups, all that good stuff. So it ticks so many boxes for me at the minute in terms of just being able to do governance, organization, and like I said, like not being locked into a vendor. Yeah,
it seems like a very logical approach, and feels like the pros should massively outweigh the cons. So the jury is out, I guess. But I think I said to you not long ago that we did a CDO roundtable only a few weeks ago, and it was quite amazing to see how many quite senior data figures hadn't even heard of a data mesh, let alone even started to democratize data and implement one. So it'll be interesting to see how it's adopted moving forward. But no, I agree with you. There's definitely a lot of potential there. Cool. So let's talk a little bit about how you would go about growing a team, I guess, from a recruitment perspective as a data leader. You've obviously got this really nice, well-rounded engineering background, a very analytical mindset, clearly. The world of data science, you've only got to look at a CV from 1 month to the next month, and there's 15 new libraries on there and tools that have come about. Obviously, it's rapidly evolving day by day. But is there a common set of traits or characteristics that you feel are really important that you would look for when hiring a quality data scientist? It can be either technical or personality attributes, but is there anything you sort of use as a benchmark for someone that is really going to add value to a team?
Yeah, I think creativity, although it probably sounds a bit cliche, is actually the key thing, because sometimes when I interview people and I ask them, how would you solve this problem or that problem, they keep repeating the same things that they've done on this one project, Right, yeah. And that's okay. But, first of all, A, did you know you were following best practice or not? And B, but what else could you do? Like being able to have people who are actively interested in like the new libraries and the new things and stuff coming out, and they have a passion for it, and they're wondering how they can combine these things, or how they can. It's problem solving, basically, is the biggest attribute, because this whole data science thing's all about thinking outside the box, especially when you think about, the first steps we often do on these things was what we call an EDA, or an exploratory data analysis. You have no idea where the data's going to lead you and what you're going to find, and theoretically you could ask a million questions, right? But having someone who's got the problem solving or creativity to ask the right questions, and then take that back to the customer and go, by the way, did you know this? And they're like, oh wow, I never knew that, straight away in my data or whatever. So I think having someone who can think on their feet, and be prepared to just go in a different direction depending on whether the data is driving them. And for example, you might have data that a tree-based model is more appropriate for that. Do you know what I mean? Or within that, which kind of flavor of that do you want? So it's really being able to be adaptive and being able to sort of like roll with the punches, but also being able to be really creative in terms of your solutions. So I've got guys on my team that are doing some really cool research in all sorts of different types of new models and things to see if we can make those so that we can help with the explainability and other things. Bridging that actuarial gap that I talked about before. That sort of lust for knowledge and pushing the boundaries is really, really important to me.
Yeah, I can believe that, and I love, over my 15 years in recruitment, I've recruited for, I guess, software engineers and data scientists in equal measure. But not casting dispersions over the world of software engineering here, but one of the things I do love about data scientists in particular is it does seem that there's a passion for understanding the problem. And actually how the solution is going to solve that problem more so than in the world of software engineering, where sometimes you can be given a spec and go, right, there you go, code that. And away you go. Whereas in data science, it does feel more of a business-centric
I think
in many ways.
I think the biggest thing that I've come across is that what I would call maybe a surface level knowledge might answer 80% of your questions or give someone enough comfort that they know what they're doing. And I've noticed a lot of candidates recently that have had that sort of slightly deeper than surface level knowledge, but they don't. Or they've had really good mentors, and so they've been doing stuff as best practice, but they don't know why they're doing it, and they don't know why that was a good idea, and they don't know actually how does that stuff work under the bonnet. And a lot of data scientists, they need to have everything set up when they turn up. Like they don't have any DevOps skills, they don't understand how parallel computing works. This stuff needs to be sort of more bled into their knowledge in terms of, how do you optimize the performance of what you're doing so it doesn't cost the business huge amounts of money with hardware sitting around doing nothing. So, or is that you could make that 10 times faster just because you did the query wrong, or that you cocked up the way that you designed the cluster and the memory and all that good stuff. So, I've noticed a scary trend. Well, I say scary. There is a layer of data scientists at the minute that know enough to be dangerous, but they don't realize there's that extra little layer below them. And it's probably, I'm showing my age here, but and that's what I try and look for as a warning, and that they, I know what I'm doing, I know everything, and but without actually knowing really how it fundamentally works under the bonnet or what it's actually doing, like for example, like in feature selection, we often use like lasso regression or something like that, something from the linear world, which is pretty incredibly powerful, but they don't know why it works. They don't know why it works. So why are you using it? So there's, being able to know why you're using the tool you're using is really, really important. And I think there's, that's the data scientists that I look for are the ones that know that detail, and they're able to fight their position on why they're doing it. And then for me, that gives me a lot more confidence in the work they produce.
Yeah, that's a good point. Do you think, Kraig, that comes from, is that a mindset, or do you think that just comes from good old experience?
I think it's a bit of both, to be honest. I think, the thing with machine learning and data science is that if you can get a toolbox and you can make a model and it looks like it's working, right? And suddenly you're like, yeah, I'm a data scientist, awesome. But then there's that old, but why? But how? Yeah. But
curiosity element.
Yeah, but is it really, learning what it's doing? The old, it's been used a million times, the one about the US Army and the tanks in the forest. I don't know if you know that one, yeah? So it's like, is it really is it just know it's a rainy day or a sunny day, or does it actually know there's a tank there, right? So it's like, that's where the scary thing is where people have enough knowledge to produce something without necessarily knowing if they produced it the right way. And the dirty secret of data science really is it's 90% of it is all data preparation and due diligence, right? The really fun stuff's only about 10%, which sucks, right? But having that process of and knowing why you're using that data, why you're using those features, and this is the model that I'm using, and I know why I've chosen that, and this is the process or the tools that I've used to get to there, and being able to justify all those steps instead of just going, oh, that's what I did last time.
Yeah, absolutely.
So that's a big deal for us.
Yeah, absolutely. 90% cleaning the car and 10% driving it.
Exactly. Yeah. Well said.
Cool. Okay. Well, great. Fantastic speaking with you. Really enjoyed the chat today. I think it's been a great episode and a huge amount of value and perspective shared. I always like to draw to a close with all my podcasts by asking for your one favourite piece of advice that you've ever received. If there's anything that springs to mind that you would pass on to your humankind, what would that be for you?
Well, yeah, there is one actually. It was I worked with an old Sparky. I didn't get to work with him very much, but when he came to head office a few times, he could see that I was getting very frustrated with the management. They didn't understand what I was trying to do, and that clearly I was, trying to do the right thing. And basically, my creativity and what was best for the business was being stifled, and I was getting very frustrated. Do you have a bleeper on this?
No, but go for it. I think that most of our audience is over 18.
Yeah, so, but he could see how frustrated I was, and he could see that I was trying to make everyone's life easier because I was standardising things and, whatever. And he just came up to me and said, "Don't let the bastards get you down like this." And I just thought, and that has been the best advice ever because, like if you've got a dream, you've got a passion, you want to do, don't let people tell you can't do it or like hold you down. You just follow your heart and back yourself, And it was the best advice I've ever been given.
I love that. Yeah, absolutely. That's a very nice way to end the episode. So thanks again for coming in. Really enjoyed the chat. Great to see you. And I look forward to keeping up to speed with all your adventures in time to come.
Thanks, guys. It's been an absolute pleasure, mate.
Take care.